Okay, we want to solve this equation. We're going to solve it by factor. So when we factor this, we get x minus 6 and x plus 3 equals 0. Now, I'm assuming we know how to factor. And we can check that. Negative 6 times x and 3 times x. Whoops. See, now I made a mistake. And I checked so that I didn't go on and do everything else. I have to do that and get the wrong results. Okay, so I'll do it this way. I'll say, well, you know, that should have been x minus 3 and x plus 6. Now we can see right away then that the negative 3x is less than the 6x. At least negative 3x out of the 6x is going to give us positive. It's going to give us 3x. Negative 3 times 6 is going to give us 18. And there's our factor. Okay. Now, you have to be able to see the numbers and understand the numbers in order to see this just by kind of looking at it. Not everybody can do that. So I've developed an algorithm for doing this sort of thing, but we're going to skip the algorithm for right now. Open Math gives you plenty of explanation as well. So we're just going to take this, and now we split this equation, and we're splitting the whole equation. So which I can just split it one side. But we split the whole equation into 2. X minus 3 equals 0, or x plus 6 equals 0. And then we solve each equation. X minus 3 equals 0. We write x minus 3 equals 0. And then we write plus 3 here and plus 3 here. Now, why would we do that? It's because minus 3 plus 3 is 0. So this side is just going to give us x. And this side is going to give us 3. Right there is one of our solutions. This equation solves similarly. We write out x plus 6. We write equals 0. And then we write minus 6 and minus 6. Because we subtract 6 from one side and get subtraction from the other. And we get x equals negative 6. And you got the or in there. Okay. This is a solution, or this is a solution. Now let's check the solution. We take x equals 3. Come up here. And plug it in with x. We get the equation. Three squared plus 3 times 3 minus 18 equals 0. Each of these x's has been replaced by 3. We square 3, we get 9. 3 times 3 is 9 minus 18 equals 0. 9 and 9 is 18. So we get 0 equals 0. And this checks this solution. We do the same thing for the negative 6. So here what we do is we plugged in 3 for x. Now here we plug in negative 6 for x. And we get negative 6 squared. And when you're squaring a negative number, you really want those parentheses, because the order of operations would give you negative 36 if you didn't have the parentheses. And maybe your calculator gets you around that difficulty, but maybe not. And we need to understand the rules for arithmetic to make sure we understand why we need the parentheses there. Then we plug in negative 6 for x here, and we still got our negative 18. This gives us 36 minus 18 minus 18 equals 0. And you can do the arithmetic. 18 and 18 is 36, and it's going to get minus 36. This is plus 36. 0 equals 0. A check mark there and a check mark there, and now we've got our solutions. There are a lot of special products in algebra, but the two most commonly used are these. So I'm going to kind of confine myself to these. Now there's a sum of two cubes and the difference of two cubes, and a bunch of other products that can be important. But let's confine ourselves right now to these, which are, if not the most important, the most commonly used, and I think perhaps the most important. Okay, so let's say we have an equation like 25x squared minus 16 y squared equals 0. Now, think about where we're going to go with this. Yeah, this is just an example of an a squared minus b squared. Okay. And not, we've been talking about equations. I really don't want to use this yet to solve an equation. An illustration for the special product. This is 5x squared minus 4y squared. This is an a squared minus b squared if a is 5x and b is 4y. Okay, if a is 5x, then a squared is the square of 5x, which is 25x squared. If b is 4y, then b squared is the square of 4y, which is 16y. We have the minus sign joining these. And that's just one example of how this product here might be applied. Okay, well, we're going to jump to actually using this to solve an equation, and there won't be an x and a y in the equation, but sometimes you have to tackle things that have more than one variable. So just a quick review of this idea. Okay, so let's now say we have x squared minus 16 equals 0. Well, x is the square of x, 16 is the square of 4. So I can write this as x squared minus 4 squared equals 0. And then by this identity, that's x squared minus 4 squared, because this is a. A is that, and b is 4. A squared minus b squared is a plus b times a minus b. So that's a plus b times a minus b equals 0. Well then, a is x, so this means x plus b, that's plus 4. And a minus b is x minus 4, and that's equal to 0. So now we can get a solution. We split the equation into two because of the zero property of multiplication. In other words, the only way the product is going to be 0 is if either this is 0 or this is 0. We subtract 4 from both sides. Here and get x equals -4. 4. Add 4 to both sides. And we get x equals 4. I'm not going to take the time to check, except just to point out if x equals 4, then we replace this x by 4. It gives us 4 squared minus 16, which is 16 minus 16, and it's 0. And if you don't immediately see out arithmetic, if you need to use a calculator, go ahead. You really should work toward being able to see that arithmetic. Also, if x is negative 4, this says you're going to square x. If you square negative 4, you get 16 again. And 16 minus 16 is 0. And that checks everything. Okay. Now I want to illustrate using the other product, and then maybe we'll do a little examples with slightly bigger numbers. Okay. So let's say now we've got 4x squared plus, let me square my d first, make this 25, okay? And this would be then 40x equals 0. That's maybe too complicated of an expression, but we're going to try it anyway. Okay. Now, is this in the form? A squared plus 2ab plus b squared equals 0. If so, then a squared equals 4x squared. So if a squared, which is squared to get 4x squared, we'd have to square x to get x squared, and you'd have to square 2 to get 4. B squared equals 25. Well, what do you square to get 25? You got to square 5. In this case, a squared plus 2ab plus b squared equals 0 becomes 2x squared plus 2 times 2x times 5. I did something wrong when I set this up. Plus 5 squared equals 0. And I get 4x squared plus 20x plus 25 equals 0. Okay, well, this doesn't match this. I hit something in my head and multiplied by 2 twice and kind of messed it up, but that's okay because this illustrates that not every equation is going to be of this form. Now, if the equation had been 4x squared plus 20x plus 25, then we'd be able to factor it pretty easily. Yes, see what I did. It doesn't match, but we solve it anyway. Illustrate, just illustrate of this formula. Okay. So this is a new equation. And this is for this form. With A equal to 2x. And B equal to 5. So we have A plus B squared equals 0, which means that 2x plus 5 squared equals 0. And 2x plus 5 squared equals 0 has two solutions. I'm out of space here. I should have planned this better. Okay, so let's just run it here. We'll have a little more space. And quantity 2x plus 5 squared equals 0 means 2x plus 5 times 2x plus 5 equals 0. So this splits into 2x plus 5 equals 0 and 2x plus 5 equals 0. Now, I don't have room to solve this, but this tells me that x equals negative 5 halves. And this tells me that x equals negative 5 halves. Of course, I get the same number because I'm squaring this thing. Okay, so solution is x equals negative 5 halves. That solution occurs twice. Now, the idea that the solution occurs twice and you break this into two equations isn't absolutely necessary, and open math might not tell you about that. It's important later on when you actually get into pre-calculus and start analyzing polynomials and try to graph them. So I mentioned it now. The equation 2x plus 5 squared equals 0 is solved as long as 2x plus 5 equals 0. And for the purposes of this course, unless open math asks you something differently, just negative 5 halves is a perfectly good solution. Okay. Let's look up. There's one more example. A simpler example. I probably should have started with a simpler example. Come back to that one. It just doesn't make sense. Okay, so we have, let's say, the equation of x squared plus 6x plus 9 equals 0. Okay. This is of this form. A equals x, b equals 3. debating about whether convert it to zero will do that. Okay. So this equation becomes x plus 3 quantity squared equals 0. Another way to solve it is x plus 3 then be plus or minus the square root of 0. X plus 3 equals 0, so x equals -3. Ignoring the fact that we have two solutions, plug -3 in here for x, we find we get 0 equals 0. Okay, that's all we're going to say about this now. I've also created an algorithm for factoring because some people, with COVID and everything, people get a little too reliant on the calculators. So it's a fairly complex algorithm, just a set of instructions. A set of instructions that will always factor a polynomial if it can be factored over the integer. So if anybody wants that, please let me know. I can send you a copy. Yeah, that's what we actually spent a lot of our class time on today, but it wasn't ready at the early part of class time. So the class was a little abbreviated. Anyhow, hopefully this will be helpful, and questions are always welcome.